Handbook of Microplastic Pollution in the Environment. Microplastic Pollution in Aquatic Environments. Edited by Tonni, Agustiono, Kurniawan, and Abdelkader, Anouzla.
Handbook of Microplastic Pollution in the Environment. Microplastic pollution in aquatic environments. In recent years, water contamination due to microplastic has become a serious environmental problem. They undergo slow breaking down processes releasing various smaller plastic particles, including microplastic and ultimately nanoplastics. Because of their small size, microplastics can spread in all environmental media, from marine to groundwater, lakes, sediments, soil, and even in the atmosphere. Although microplastic pollution is a global environmental problem, microplastic in the marine environment represents an unexpected change in the aquatic environment due to their size of 5 millimeters or less. Particles with grain size less than 1 millimeter is designated as microparticles. This makes it difficult for naked eyes to catch. According to the United Nations, about 70% of the world's inhabitants will live in cities by 2050. With the growth of megacities worldwide due to rapid urbanization and industrialization, microplastic enter water bodies through different pathways, including atmospheric deposition, runoff from contaminated land, or through municipal wastewater. It is anticipated that the demand of clean water for domestic, agriculture, and industry would rise by 80%. Unless immediately tackled, 36% of the cities will experience serious water pollution that derail their progress in the long term. These outstanding issues need to be addressed in a sustainable manner. These fine plastics, via surface runoff and wind action, reach our surface and groundwater storage and enter into aquatic environment, where various aquatic organisms like fish, shrimps, turtles, zooplanktons, mammal ingest these microplastics. This ingestion poses lethal impacts and serious threats like decreased growth rate, mechanical injury to the organism. Furthermore, they can be vector for various chemical or microbial contaminants. Inevitably, these particles can enter into the food chain, with largely unknown effects on human health. In some cases, microplastics are so hazardous that they even cause death of respective organisms. Water pollution by microplastic is complex and multidimensional, and managing it effectively requires a range of responses. This book compiles a variety of contributors to deal with current microplastic pollution in different parts of the world, particularly on the remediation of aquatic from microplastic contamination. Microplastics represent resources that are traditionally undervalued or not valuable at all. The generation of microplastics has increased recently and become an emerging issue worldwide. Microplastics are highly resistant to degradation, leading to their accumulation in the environment if not reused or recycled. Contamination by the pollutants in freshwater and agricultural soils represents serious threats to the environment with respect to its quality, biotic life, and sustainability. The microplastics exhibit a global distribution in the freshwater and agricultural soil due to an improper littering of plastic waste and its degradation into smaller particles. It is estimated that 15 to 51 trillion microplastic particles have accumulated in ocean worldwide, weighing between 93,000 and 236,000 metric ton. To address the existing knowledge deficit, this volume encompasses 29 chapters that delineate the multifaceted challenges and opportunities associated with addressing microplastic pollution through diverse water technologies. The text presents innovative viewpoints on enhancing the management of microplastic in aquatic ecosystems. Enhanced management of microplastic could promote.
Okay, let's talk about a threat that's pretty much everywhere. In the air, in our water, even inside us. It's an invasion that's happening on a scale so small you can't even see it, but its impact is, well, it's huge. We're diving into the world of microplastic pollution. So, to really get a handle on this, you have to start with this number, 430 million. That's how many metric tons of plastic we produce every single year. It's an almost unimaginable amount. And the really crazy part? A huge chunk of that is made to be used just once and then chucked away. You know, plastic is, in a lot of ways, a wonder material. It's cheap, it's light, and it's built to last forever. But that's the catch, isn't it? The very thing that makes it so useful, its durability, is exactly what turns it into an absolute environmental nightmare. So here's how we're going to break this down. First, what exactly are we dealing with? Then, we'll look at just how far this stuff has spread. After that, we'll get into the real dangers, check out the incredible science fighting back, and finally ask the big question. What does this all mean for our future? All right, let's start at the beginning. Before we can really talk about the threat, we've got to be clear on what these invisible plastics actually are. So what are we talking about here? A microplastic is any piece of plastic that's smaller than a sesame seed, and that's the upper limit. They get so small, they are literally microscopic. And that tiny size is the key. It's what lets them travel all over the planet. And it turns out they come from two main places. You've got your primary microplastics, which are actually designed to be tiny from the get-go. Think of those little microbeads they used to put in face wash. But the vast majority are secondary. These are the little bits and pieces that break off bigger things, like water bottles, plastic bags, or even the synthetic fibers that shed from our clothes every time we do laundry. Okay, so we know what they are. The next question is a big one. Where are they? And the answer, honestly, is pretty shocking. The journey is simple, but totally relentless. A plastic bag gets loose, right? The sun and the ocean waves just beat on it, breaking it into smaller and smaller fragments. From there, wind and water currents act like a global taxi service, just carrying these tiny pieces everywhere until they finally settle into ecosystems and, yeah, inside living things. And when we say everywhere, we're not kidding. Scientists have found these things in the most remote, untouched places you can imagine. We're talking the bottom of the Mariana Trench, the top of Mount Everest, and locked away in Arctic ice. They are, quite literally, everywhere. And this is where it stops being an out-there problem and becomes a deeply personal one. It's not just in the environment anymore. We are now finding microplastics inside of us, even in human placentas. The stuff we throw away is coming back in the most intimate way possible. All right, so they are everywhere. We've established that. But does it matter? Are they actually dangerous? The answer is a definite yes, and for reasons that are way more complex than you might think. I mean, it's easy to think, they're just tiny bits of plastic, what's the big deal? But it's so much more than just inert little specks floating around. So what is it that makes them a real threat? Well, here's the twist. The plastic itself is only part of the problem. The real danger, it turns out, comes from the toxic hitchhikers these particles pick up along the way. This is the key. You have to think of microplastics as tiny, toxic sponges. As they move through the water, their surfaces grab onto and concentrate other nasty pollutants, things like heavy metals and pesticides. On top of that, they're also leaking out the chemical additives they were made with, like phthalates and flame retardants, so they become these little super concentrated poison pills. And it gets even weirder. These toxic sponges don't just attract chemicals, they attract life. Microbes love to colonize their surfaces, creating this slimy layer called a biofilm. This has created a brand new human-made ecosystem that scientists have actually named the plastosphere. And this eco-corona has some pretty serious consequences. It can act like a little raft for harmful bacteria, giving them a ride to new places. It can even become a breeding ground for antibiotic resistance. And that slimy coating makes the plastic look and feel more like food, which means it gets eaten by fish and other wildlife, officially entering the food web. Now, I know, listening to all this, it's easy to feel pretty overwhelmed. But the story doesn't end there. There is some incredible science being done right now to fight back, to track this stuff, manage it, and even get it out of the environment. The response is basically happening on two fronts. First, you have the detectives. They're using AI and satellites to map where the pollution is worst and predict where it's going. And then you have the cleanup crew, a whole new field of science dedicated to actually removing these particles from our water. And some of the tech is just amazing. Take biochar. It's basically a kind of super advanced charcoal made from waste, and it can be used to create filters that trap almost 100% of microplastics. Then you've got these other processes that use powerful oxidants to do something even crazier. They don't just trap the plastic, they actually break its chemical bonds apart. So, we've looked at the scale of the problem, the hidden dangers, and some of the amazing scientific solutions taking shape. So, what's the bottom line? What are the big things to take away from all of this? If you remember just a few things, make it these. First, the amount of plastic we produce is just off the charts. Second, that has led to a contamination problem that is truly global, from the highest mountains to inside our own bodies. Third, the real danger is that these plastics are toxic hitchhikers. And finally, and this is the hopeful part, science and innovation are giving us real tools to start cleaning up this mess.
And that leaves us with one last, really big question. Technology can help us with the cleanup, for sure, but it can't fix the problem at the source. So the real challenge isn't just about science, it's about us. Can we fundamentally change our throwaway relationship with this material that's both so useful and so incredibly destructive? That's the question we have to answer.